Hello everyone. Let's start the session now. Today's agenda is to get some brief understanding about Bitbake, how it works, what it understands, and how we can clone the repo and how we can start working with it. I hope I am audible to you. Okay, let me share my screen. For today's session, I am going to use open source documentation from Yocto itself. As you can see, it is docs.yoctoproject.org. Once you go to this site, you will find several documentations like overview, BSP documentation, kernel doc, ESDK, Bitbake. From that, I am using this Bitbake documentation. It will just give you some brief and then you can click here and this will jump this location. Yeah, I think you all can see it now. This is the Yocto's documentation of Bitbake. As we discussed in last session, what is Bitbake? That Bitbake is a generic task execution engine. So whatever images it builds, everything is done by Bitbake itself. So what Bitbake is made of? There are several Python scripts, shell scripts that it is made of. Whenever Bitbake start its execution, it will look through all the metadata available to it. It will create a list of tasks and it will start running them. To run these things efficiently, it will do all things parallelly. Like if your computer or if your server has multiple processors, it can use all these processor at a time so that the build can run fast and it can finish as soon as possible. As I mentioned, it interprets some metadata. So what kind of metadata it interprets? This sentence is mentioned here that it understands this metadata. Now there are several metadata available in Yocto project. The basics are recipe, classes, and configuration files. These three are main metadata. Without these three, Yocto project is not exist. Apart from this, there are two more metadata called bbappend and include files. Now what these all are, I will explain this detail by using Pocky's web repo. In last session, I explained you what is Pocky, what is OE core, and what is Bitbake. I showed you this web repo as well. As you can see, there is Bitbake here. OE core is available. And some Pocky reference distribution stuff is available here. Now let's take an example that you have a C code, just main function and printf. Now you want to build that executable from it and you want to use Yocto project. How you will do it? As you see, there is a layer called Metaskeleton. When you go through this layer, you will find several recipes available to understand Yocto project better. Several recipes for kernel, for images, some bare metal recipes are also available. You should go through this readme file once. I'm not going into details right now. I'm just going to this recipe skeleton. In this recipe skeleton, this hello single, let's take this example. Our aim is to create executable from normal C code. I'm opening this Bitbake file. So this is the Bitbake file. Here it is mentioned hello world.c. Don't think about this, all this stuff. Whatever you don't understand, just leave it. Just see that there is one hello world.c file mentioned here. Now, this is your C code. If you go to this Metaskeleton, recipe skeleton, hello single and files, you will see hello world.c is placed here. As I said, there is a main function, printf, and return statement. This is a normal C code that we are intended to create executable for. And this is the file where you mention what do you want. Okay, this is your source file. You want to compile this file. To compile, you don't have any makefile here. If you see, there is no makefile. So what you want to build, you have to mention it. So there is a function called do compile. Here it is mentioned .c file output hello world. Okay, I guess you all are aware about this stuff at least, and how to compile it. So the first file you should use to create your binary is called recipe file. This is recipe file. Extension is .bb. So recipe file is the first file you should locate. You should create your own file and you should mention some stuff here. You understand this stuff right now, so it's fine. Linux kernel developers might also understand the install stuff. But let's talk about that later. In Bitbake's documentation, this is the first file we see, recipe. Okay, I guess you all have understood what is recipe file, right? First file you should create to compile our C code. Let's take one more example. Hello Auto Tools. For those who understand Auto Tools, it's just one of the build system. If people are not using makefiles directly, can use Auto Tools. Auto Tools will create the makefile on its own, right? This is a recipe file which compiles the same C code but using Auto Tools. If you see, the C file is not mentioned here. Like we see in source URI here, the C file is mentioned. Here, there is a link mentioned. A tarball is given here. It's from GNU mirror. So this variable is pre-available in Yocto. We will see what all the mirrors are available. But this link is referring to this. This is the mirror. This is hello. Okay, this is mirror, hello, and the file name. So hello and file name. Okay, as you see, it is mentioned hello hyphen pv tar gz. For time being, pv stands for package version. So package version is 2.10. The recipe file name itself contains the version. So if we locate 2.10 tar.gz, it's here. Now let me share what this tarball contains. I guess you can see that I have already downloaded this tarball, have extracted it, and I am into that directory. For those who understand auto tools, might also aware about configuration file, authors, AC local, makefile in. So these are the pre-required auto tools files to create your own makefile. We won't go into this source and what all the other stuff are there. We are just here to see what auto tool need, right? Here, if we see the recipe where auto tool is used, the tarball is mentioned. And there is a line mentioned inherit auto tools. Let's not go into these details. Let's just see that there is some inherit used with auto tools. Now here, what Bitbake will do is, Bitbake will locate this tarball. It will first see if it is already downloaded or not. Okay, if build is triggered for the first time, it's obvious that tarball is not downloaded. So it will go to this link and it will download the tarball. Once it download it, it will extract that tarball and put it into some folder. Once this step is done, it will then call the auto tool functionalities. But how? So then this line do the magic. Now let's see what is this. If we go to Pokey source tree, we see this meta. Now you must know that this meta is from OE core. Okay. Now let's go to this class folder and you can see the exact name used in the recipe, autotool broken SEP. So one file is present here with the same name. One more file is present with just auto tools. Let's just click this auto tool. The extension is bbclass. What this file contain is all the basic level of understanding what auto tool is doing, how it build the binaries, but all the common logic is present here. How it configure it, right? The configuration file, whenever you trigger the build, how it should behave, everything is mentioned here. So what Bitbake will do is, after extracting the tarball, it will just run this auto tool from this. So the extension is bb class. Now if we go here, one more metadata is present at class. Okay, so now class file is something which will contain the base information or base metadata which can be used across all the recipe files, right? So like this hello, you can bring your own source and you can use inherit auto tools which will trigger the build. Now class file contains the base which can be used across all the recipes, but recipes are specific to your code only, right? I hope you are getting. We covered this too. We'll go into the details later. Now three metadata remaining. Three metadata are remaining: bbappend, configuration, and include. Now let's go into this documentation to understand what is what. As I mentioned, recipes are denoted by extension .bb. This is the most basic metadata because you are going to work on that whenever you want to do something. This is the first file you should create or should modify. What information it contains, how to configure, compile the source code, where to fetch the source code, either by C file or by tarball. Should mention it, how to fetch it. Okay. Dependencies and these things we will see later. After that, we saw class files denoted by bbclass extension. What it contains: information that is useful to share between metadata files, share between recipe files, right? We just saw it. There are some other information as well, like how to configure it, compile it, install it. As we saw, there are some configuration options available. It will contain everything: how to compile it, how to install it, right? Now let's see append files. It is similar to bb file, right? It is denoted by .bb_append. What it is used for: if you want to add something to your bb file, right? Let's suppose you have added some more source codes and you want to add it in your recipe file. So Yocto don't advise to modify your existing bb file, and that's why they have created .bb_append. So if you want to add your source code or add some more files, or you want to change how it should compile, let's suppose in development you are just trying this stuff, but now you have created more source codes and you have applied auto tool functionality in your source code. So you have to change source URI, you have to change how to compile it. So to do all the modifications, you should use .bb_append file, right? To extend or override information in an existing recipe file, you should use .bb_append. One thing is needed, that every append file should have a corresponding recipe file. So bbappend, if this exists only. Let's suppose there is an application called form factor. You have bbappend, but your layer is not having .bb. It doesn't work. Let's suppose some other layer contains this bb, and your own layer contains this bbappend. So you should add that layer in your build target, right? So bb append is to extend or override something. It should have corresponding recipe file. Now, how to name it, how these things work, we will see later. This is just to explain what is what. So recipe file is done, append file, class file. Now let's see configuration files. As you saw, recipe file is particular for your source only. Class files are the base metadata which can be used across your recipes. Now, the conf files are something that is global. If you see, the meta layer itself contains a conf folder. There are several configuration files like bitbake.conf, layer.conf, documentation, distro specific, multilib, ABI version. Okay, so these are the configuration files and these are global. Let's see one of the example. Let's suppose bitbake.conf is there. Now if you see, this will contain all that variables, the paths, everything. So if someone is using this prefix variable in their recipe, it will just interpret this path. So likewise, your whole working directory can use this type of variables. Okay, as this configuration file is global, it can be used anywhere in your build directory. But if you specify something like this in your recipe file, let's suppose you mention this type of thing in your recipe file, you cannot use it in other recipe. Okay, so for that, these configuration files are used. As you see, it is denoted by .conf. It defined various configuration variables. We just saw that. These variables can govern the build process as well. We just saw a sample of bitbake.conf. Okay, it will provide user configuration, common configuration, compiler tuning, distribution configuration, right? We saw the distro folder, also machine configuration. If you have your BeagleBone hardware, you write something for your BeagleBone, you can create a configuration file for your BeagleBone. So each build directory will reflect your changes if it is intended for BeagleBone. So one change can reflect your whole build directory. Okay. We saw recipe, class, append, configuration. One thing left is include files. Okay. In normal C code, we see or we write that hash include stdio.h. So what it is, it includes some base functionality to use across your whole source code. Similar way, this include file will contain some common code, but not a common code like class files. Let's suppose you have a recipe of Linux kernel. Let me show you from here. Okay. We are in meta, recipes kernel, Linux. Now, as you can see, there is a recipe for Linux Yocto RT 5.1, 5.10 means 5.10 version. One more Bitbake file Linux Yocto RT for 5.15 version, right? Let's open this both files. You see some common code here. Source URI. Same source URI is used. Same. You see there is slight difference in both these recipes. You see this version is changed. This source revision is changed. Nothing else. So why they are writing these two recipes where 70% of the information is same? To make this common code in one recipe, I can cut this thing and I can put it in some common file and I can use that file in both these recipes, right? As there is a slight difference in version and all. If I cut this stuff and put it in some file and include it like we do in C, if I include this file in this both recipe, that will ease the process, right? If I want to create one more recipe like Linux Yocto RT 5.20 version, I can just use include file and I can mention the revision and the version, just that. Okay, so for that kind of purpose, include file is used. Here they haven't used it, but I guess you got some idea what is include file. Version independent code can be put into include file. Okay, this is version independent code which is present in both this recipe. This and this is version dependent code. For this we can use a recipe file. For other stuff we can put it into that include file. You see how they are including it. They use a variable called required and they mention the name of the file. Okay, I hope you are getting what is include file. Version independent code will go to include file and independent code we will use recipe file. So that is all the metadata Yocto has. Nothing more than that. Right? Let's see what Yocto's Bitbake's original goal. Bitbake can create cross-compilation tools. It resolves inter-package dependency and all. There are several. This list is big. We'll understand each and everything one by one. Okay. This our SAP's configuration class append include. Let's see what layer is called here. Okay, this is a layer, meta self-test. Whatever start with meta, that is called a layer. So what layer can contain? Some class files, some configuration files, some recipes, some library files. So the whole collection is called a layer. We saw this Metaskeleton. This is for understanding purpose only. If we see recipes kernel, we can see, right? They included this Linux Yocto include file. They just mention the version name, source revision, the name they have added, custom here, this stuff. So layer may contain machine configuration, some recipes, append files, recipe files, class files, and configuration file. It allows you to isolate different type of customization from each other. Let's suppose for Raspberry Pi, we create a layer. We can name it as Meta Raspberry. Now we have one more hardware called BeagleBone. So we will create one more layer called Meta BeagleBone. So the metadata specific to BeagleBone will go to there. The recipes, whatever we create for those hardwares, we put it in those layers. So that will isolate all the customization from each other, right? If anyone new is there, they want to explore, then you give the hardware called Raspberry, so they can directly go to Meta Raspberry, and then they can go through what all we have, right? So that is what layer is called. Okay, so metadata is done. So this is something which you should do. If you have cloned Pokey and started the build, that's what people do. They just do Bitbake core image minimal, but I don't recommend that, because you spend more time in building this stuff, and at the end you will get the images, but what you will do with the images if you don't have understanding. So I recommend, before cloning Pokey, everyone should clone Bitbake. The information is there in documentation itself. I'm not going to do this practically like this, not going to explain what you should do. Please try to do this Bitbake clone, or you can fetch the tarball and extract it, but better to clone it. You look through all the branches, all the tags they have, you can go through the changes what they have made. Once you clone it, you see you can fire that Bitbake command that will invoke the script, and you can check the version. You can parse something, or you have this type of recipes, you can directly check that out. Okay, they have several examples how to create, what task it has. All the information is present in the documentation itself, right? So this way you will see that Bitbake can run standalone. It doesn't need Pokey or OE core. You can use Bitbake as a separate entity. There are some examples given here, what to do with it. Okay, I better suggest you that just try whatever is there mentioned, just try that stuff only. That is sufficient. Or if you want to explore something else, you can just go through the documentation and explore it. See, you can build something directly using Bitbake. You don't need anything else. Now today's agenda is complete. Whatever I wanted to show, I have just explained. Don't go with this multi config stuff right now. Just up to this, you can try and perform. We will see later what is multi configuration and all this thing. Okay, so if you have any questions and doubts, you can just raise it.
Yeah, hi Milan. My question is like, is it compulsory to provide package version name with recipe name?
There is no need. Uh, just let me share the screen again. I will show you. Uh, you see, there is a recipe name here, Linux Yocto Custom BB, and we
Hmm.
saw one more recipe called Linux Yocto RT 5.15. So in one recipe they have mentioned the version one, it's not mentioned. Then how Bitbake will get to know the version? Just simply it will parse the recipe. Here the PV variable is mentioned. It is made of Linux version plus git and source PV, right? So Linux version is mentioned here, and source PV is, I think, directly fetched from this. Okay, so eventually your version will be 4.2 plus git and then this revision number. So it's not necessary or compulsory to provide PV in while naming your Bitbake recipe.
Okay, yeah, and let's see. Assume we haven't provided any any packet version to the recipe, and let's say we use the PV variable inside the recipe. So, like, what to content will be in PV? Like, it will give some error, or it will taking some by default variable, a value of that PV variable.
If let's suppose we are not mentioning PV inside a recipe or while naming it. So and also you are not providing any tarball, you are just providing directly source files. So
Yes, and just
it
we are using somewhere in like, let's say we are not using in the naming convention, but let's say we used PV packet version somewhere in our recipe by mistake or something. So is it providing error, or like as I believe, I think packet version is a local variable, right? Or is it also global variable?
No, whatever is mentioned inside your recipe is local only. So when
Okay.
you are providing PV inside your recipe, Bitbake will understand it. It won't give you any error. It's totally valid, and it will pick that package version name from there only.
Okay. Okay. Got it. And if we provide into the naming convention of recipe, then it will extract for that naming convention, right?
Yes.
Okay, yeah, thanks.
Any other questions? Okay, I guess no questions are there. So I hope you understood what is metadata, right? What all the metadata is. Okay. Okay, then let's wrap up here only. I will share the link of this documentation. Also, this video will be uploaded soon, so I will share the link as well. If you have any doubt, you can watch it there, or you can raise questions there. Right? So, okay, then let's end this call. Thank you
Yeah,
everyone for
thank you, Milan.
joining. And if you have any question, then you can raise it in a WhatsApp group, or you can raise it in Google group as well. I hope you have all seen that build root versus Yocto's difference. God, I have mentioned most of all the points which are there, right? Okay.
Yeah,
Okay,
thanks,
then
Milan.
Yeah,
Bye.
thanks everyone. Let's
Thank you,
wrap up.
Milan.
Yeah.
Thank you.
Okay. Okay. Bye.
Yeah, thanks, Milan. It's too much informative. So thank you once
Yeah.
again.
Thanks. Thank you very much.